As I mentioned, this course is going to help you master JavaScript. And after you do that, all the other doors are going to open for you. You can jump into React, for example, and start building large and extremely useful applications. Or maybe you decide that backend is more your thing. So with all the JavaScript knowledge that you gain from this course, you're going to start learning Node.js to create complex systems and APIs for applications such as e-commerce stores or even social media networks. In the next lecture, you're going to receive the access code for a special 24/7 community where you will be able to ask any questions you might have during the course, or you can use it for networking with fellow aspiring developers. Let's start making you a professional developer right now. Before starting with the course, let's first set up the needed tools and environment so that our workspace will be comfortable and convenient for performing the best JavaScript work possible. Throughout this course, we are going to use Google Chrome. It's the best browser for web development. It has the fastest engine and is used by over 82% of people. It's one of the best choices out there. So, if you don't already have it, here's how you can download it. Just go to google.com/Chrome. There, you will be greeted with this page and you can just download it for any operating system. One of the best reasons to use Chrome is because of its amazing developer tools. Developer tools allow you to do a range of things, from inspecting currently loaded HTML, CSS, and JavaScript to showing which assets the page has requested and how long they took to load. You can open DevTools in any browser by right-clicking the site and clicking Inspect right here. This is going to open the developer tools. You can also use the shortcut Command-Option-J on Mac or F12 on Windows. So you can see this is the Chrome DevTools. Now let's close it and try using the shortcut. So one more time, Command-Option-J on Mac. Let's see if it's going to open it. And it does. And you can do the same thing on Windows with F12. That's it. Let's close these warnings here and let's explain what developer tools are. In essence, developer tools window is very intuitive and you will easily get used to it, as it has all standard bars like console, elements, sources, and so on. We're going to use them throughout this course. Let's test out the console section. In there, you can execute JavaScript code. And that's the place where all of our console logs are going to be visible. We're going to use it a lot. This is going to be the first line of code that we're going to write. So you can say console.log and then wrap it in parentheses. And inside of there, in quotes, you can write anything you want. People usually do hello world. So if you take that and press enter, you can see we've just written our first line of code and we can see it right there. Of course, we are going to do much more interesting stuff later on. With this, we now have the ability to see websites we can create. But using which tools can we create them? Code Editor is a program that lets you write and edit code. Theoretically, you could use Notepad, which you get with your Windows or TextEdit on Mac, to edit and write code. But people have created much better alternatives which give you a lot of settings, themes, code highlighting, easy navigation through documents, and much more. You're free to choose from various code editors available, like Atom, Sublime, Brackets, but in this course, we'll bet on Visual Studio Code created by Microsoft. It has the largest community, great support, and a huge variety of extensions, plugins, and themes which you can use and experiment with. So, how can you download Visual Studio Code? You can just Google Visual Studio Code download. And as you can see, you can download it on Mac, Linux, or Windows. Let's open the link and see what we have in there. We can close the console. As you can see, with just one click, you can download it for your operating system, and the process of installation is going to be pretty straightforward. Once you install it, we're going to go through a quick Visual Studio Code tutorial. Once you start the program, you should see a nice interface and something like a welcome file opened. In the right part of the file, there's a section called Learn. There you will find all the info from keystrokes to how to change your theme. Feel free to explore and play around. However, now I want to show you how to create a basic HTML file and integrate it with JavaScript. First, let's exit the full screen right there. Then you can open File Explorer or Finder if you're on Mac, and you can create an empty repository, or that's just going to be a folder. I created mine. It's called Introduction to the Course 01, and you can just drag and drop it right there to Visual Studio Code. Once you open it, you'll see that we have this timeline. You may have a lot more stuff here, but the only thing that we're concerned with is this part with the folder name. You can expand that. Right now, you can create a new file by right-clicking, clicking New File, and then you can type the file name. In this case, it's going to be script.js. That's immediately going to open the file for you, and in there you can say console.log, and then again in quotes, hello world. This is the same line we've written in the console before. You can save it by pressing Command or Control S. If the file is not saved, on top right you should see the circle right there, but when you save it, the circle is gone. That means the file is saved. The question is, how can we run that file? Well, here we need the browser. And what does the browser need? It needs HTML. So we can come here one more time, create a new file, and call it index.html. Inside of here, we just need a basic HTML structure. You can type HTML, and then Visual Studio Code is going to give you a few options. You can just select the HTML5, and this is immediately going to generate basic HTML structure. The only thing we need to add is a connection to our JavaScript file. You can add it just above the closing body tag, so right there. You can type script, and right here, before the closing of the opening tag, you can type src, which is going to be equal to script.js. This now means that our files are connected. You can now right-click the index.html file and then click Reveal in Finder or in File Explorer. Now this is going to pop up and you can just double-click the index.html, which should open it in the browser. Of course, we just have the empty page, but if you click Inspect or just open the Chrome Developer Tools, you should be able to see we now have the console, which should mean that our page is successfully connected to JavaScript. What can you see in the console? Hello world, right? That's what we expected. You've just created your first basic JavaScript program. Congratulations. We've set up all the basics of Visual Studio Code, but before we start learning, we want our environment to be as good as possible so that we can learn and write code quickly. For that reason, we're going to install a few extensions which provide extended functionality. Some make our theme prettier, and some allow us to see live changes in the console as soon as we save the file. So let's install them one by one. The fifth icon on the left side should be the Extensions tab. So you can find it right here, Extensions tab, and then in there you can install the extensions we need. The first extension on our list is called OneDark Pro. That's going to be this theme that you can see right there, because right now the colors could be a bit different for you. You can click it, and then that should open the extension page. Right there should be a button Install. Once you install it, it's going to ask you whether you want to switch to it, and you can just press enter. As you can see, our code editor instantly looks a bit more modern. The second extension on the list is called Live Server. You can search it up, Live Server. Once we find it, it's going to be the first one on the list, and again, you can click Install. Now, if we go back to our index.html file, you can find it on the left side, right-click it, and you should see this message, Open with Live Server. You can click it, and we'll be using that to test our JavaScript code. A new empty browser window is going to open up. Don't forget to open the console by right-clicking and then clicking Inspect. And now we should see the same thing we saw before, but in this case, it's always going to update whenever we add something new. As you can see, Live Reload enabled. In the next video, I'll show you how to have the console opened side by side to the editor, so we'll be able to see all JavaScript responses in real time. In this short video, we'll talk about our workflow. It's important that you know exactly how we are going to do something so that you can replicate it or practice by yourself. This course is going to be divided in sections. In between sections, we are going to have special projects, but more on that later. The workflow is going to be as follows. First, we are going to open an empty folder. We just did that before. As you can see, if we collapse this, you can see that we opened our empty folder, which now has 2 files. After you open your empty folder in Visual Studio Code, we are going to create those 2 files, index.html and script.js. Really important step, of course, is to connect them by adding the script tag in the HTML file, and you can easily do that by adding this line right there. To make sure your files are connected, you can add a simple console log in the script. If it shows in the browser, that means that we've successfully connected it. After we do that, you're going to go to index.html and then just click Open with Live Server. That's going to open it so that we can see changes in real time. So, how can we open the console and the code editor side by side? First, open the console by right-clicking and then clicking Inspect. On the top right, you're going to see 3 dots right there. I hope you can see them on the screen. And there you can find the dock side. You're going to choose the first option, undock into separate window. This is going to open the console in a completely new window. So what we can do on Mac is unfull screen this and just do it like this. Open the console, put it on the side. But now we have some extra space here. So what Macs allow you to do is to just open it full screen, go back and then open the Visual Studio Code in full screen as well, and then just merge them together. So find the actual DevTools, find the code, and just drag it onto the side right here. That's going to enable us to have both open at the same time. Don't worry, the process on Windows should be even easier. You can just take the window of the console and drag and drop it to the left side. That's it. Really, really simple. With that out of the way, we now successfully put our console to the left side and the code editor to the right side. If these warnings bother you, don't worry, this comes from Chrome itself, but we can remove them by going to this settings icon and then selecting selected context only. So if you tick that, the errors should be gone, and that's it. Now, how can we test it? Well, because we are using live share, you can just type console.log, so we can just add another console log, and let's just say test. We add that test. And remember, we need to save the file. So currently you can see this dot here. That means the file is not saved. So if we save it and do that, you can see that our console is immediately updated. That's great. One more thing that you can do is with Control or Command plus or minus, you can bump up the font size. Feel free to do it as you like it. You can do the same thing for Visual Studio Code as well. I like to keep it like this. And with Control or Command B, you can completely collapse this thing, or you can just press here. Now we have just our console, the font is big, we can see all the changes, and that's it. We've spent some time to set this all up, but it's going to save us a lot of time in the future, because right now our environment is completely set up, everything works, and our workflow and learning process is going to be amazing. That's all that we need for now. Go and grab a cup of your favorite drink, cool down your brain, and let's dive into real programming. Welcome to the first section of the course. In the next few videos, we are going to explore topics of variables and data types, 2 of the most important concepts in any programming language. Variables are used to store information to be referenced and manipulated in a computer program. They also provide a way of giving variables a descriptive name, so our programs can be understood more clearly by the reader and ourselves. It's helpful to think of variables as containers that hold data through the entire application. The sole purpose of variables is to store data in the memory. These 3 boxes represent 3 different variables. Let's say this variable is called box1 and it stores the value of Bob. The second variable can be called anything, it can be called test, and the test stores the value of true. The third box, which is the third variable, stores the value of a number 35. As you can see, variables in JavaScript are containers which hold reusable data. In other words, they are units of storage, like some sort of a box into which we can put data. Using the following steps, you can create and use variables. So first, we need to create a variable with the appropriate name. Secondly, we have to store value in it. Thirdly, we have to retrieve and use the stored value. And optionally, you can change the value and then reuse it again. Now, let's open our Visual Studio Code and see it in action. As always, we have our Chrome opened. Then we're going to have our Visual Studio Code, and we're going to create a folder which is going to have two different files in it. We have index.html and script.js. I call this file 02 variables and data types. We're going to drag and drop it here. As always, make this full screen, and then in there, don't forget to link this to the script. And let's say console log. In there, we're going to say welcome to variables. And that's going to open the browser for us. In there, we don't have anything in the browser, but if you inspect it, then you should be able to see the console open. If it's not opening in the new window for you, go click these three dots and then click undock in separate window, and then just drag it to the left side of your actual window. That's it. We have the console open on the left side and the Visual Studio Code on the right side. In here, you can click this wheel and click selected context only to remove the errors. And if you save it, we should get welcome to variables. Great. Now we're good to go. So the values that we store in our variables can come in the form of predefined data types. The computer needs to know of which type is our value so it can manipulate it properly. The lecture on data types is coming really soon in the course, and it's going to explain all the details about them. So how can we create a variable? We need a var keyword. So let's create var. In there, the second thing we need is the variable name. So let's say variable name, just like that. Then after the equal sign, we put the value which we want to assign to this variable. Right now, let's take the value of this console log, welcome to variables. Let's copy it, paste it here. That's it. So right now, what we can do is we can take this variable name, which is a variable, and put it in the console log. Remember, variables store some values. In this case, we put the value of a string, more than later, in here in this console log. If we save that, you can see currently it's not saved because of this circle. If we save that, you can see we get absolutely the same thing in the console. We've successfully used our first variable. Just a simple note, you're always going to see me adding semicolons at the end of lines, as you can see here on line 1 and line 3. Also, if you don't know what lines are, on the left side you can see we have different lines. So our programs later are going to have 10, 50, 100 lines. So whenever I say something is on line 1 or line 3, you can just see it on the left side. So we use semicolons. They are optional, but omitting them can lead to undesired consequences. It's a good practice to always put them at the end of the line, and you'll often see me doing that. In the next video, we're going to see 2 more additional ways of creating variables. In earlier versions of JavaScript, variables were solely declared using the var keyword, followed by the name of the variable and a semicolon. So let's see, var variable name equal sign, the value of the variable, and then the semicolon. This is how we would do it. After ES6, which is a newer version of JavaScript, we now have 2 new ways of declaring a variable. We can take a look at both of them one by one. The variable let, so we can exchange this var to let. The variable let shares lots of similarities with var, but unlike var, it has some scope constraints. The scope is out of scope of this introductory video, but we will explain it in greater detail in a later video. The only thing that you need to know right now is that let is the preferred way of creating variables in modern JavaScript. So we would do it like this, let variable name and then the value. We also have something known as a const. So let's write it right there. Const. Const is another variable type assigned to data whose values cannot and will not change throughout the whole script. So if we say const variable name is going to be equal to this, we can never reassign variables. What does it mean to reassign variables? Well, let's first go back to let, as we said that is the preferred way of writing variables, and now let's try to reassign the value. So we can then reference the variable name, right there, variable name, and then we can make it equal to something else that is not its initial value. So let's say hello. So right there, I'm going to say variable name is going to be equal to hello, and then we are console logging it. Remember, to see the output, we need to save the file. So right now, I'm going to save the file, and in the console, we get hello. So how did this program execute? First, we declared a variable, we gave it a default value. Then we reassigned the variable, or just we gave it a different value right there to the same variable. And then we console logged it. If we added another console log right there before we changed it, so let's say we want to console log it first, and then we want to console log it after the reassignment, we can save that one more time, and you can see we first get welcome to variables, and then we get hello. If we were to do that with const right there, const variable name, and in here we are redeclaring it, you would get an error. Uncaught type error, assignment to constant variables. That means that we can never reassign values to a constant variable. So if we remove this, now what do you think? Can we name our variables literally anything we want? Well, we have only a few criteria when it comes to creating variable names, also known as identifiers. We have a few rules when it comes to creating an identifier in JavaScript. First rule is that the name of the identifier must be unique. So as you can see, if we copy this and then paste it, you can see we got an error. We broke the first rule. Identifier variable name has already been declared. That way we get an error. We don't get our console log. So we broke the first rule. If we rename this to variable name 2, and then let's say try to console log it, variable name 2, and we can even change the value. Welcome to variables 2. Let's save that. And as you can see, we got both console logs there. We didn't break the first rule, which is never have two of the same variable names. The second rule is that the name of the identifier should not be any reserved JavaScript keyword. For example, we cannot declare a variable like this. Const let is going to be equal to welcome to variables. If we try doing that, let's see what happens. Uncaught syntax error, let is disallowed as lexically bound name. We can also try const var, because we know that the var is a specific thing in JavaScript. It means a variable. So we cannot call a new constant or a new variable var, because that's already reserved. So if we try doing this, we get the same thing, unexpected token var. Let's try a few more reserved keywords. We know that const is also not going to work, unexpected token const. And let's say const function. Function is also a reserved keyword. We're going to see that later. So if I try doing this, as you can see, unexpected token function. That means that we cannot use names that JavaScript itself uses. Those are only some limited reserved keywords like var, let, function, and so on. We are going to explore all of them, but basically you can use anything you want. For example, you can say name, and then you can put this to John or whatever, because name is of course not used by JavaScript. That would limit us a lot. So if we just did this, we are console logging the name John. The third rule of naming variables is that the first character must be a letter. In here we have a letter, an underscore, so we can do underscore name as well, or it must be a $sign. So only $sign, underscore, or any other letter are valid first letters for your variable. That's it. If you put any other special character at the first place, for example, let's say an asterisk sign, you can see immediately we get an error, unexpected token. That's not going to work. All the other characters, besides the first one, can be any letter, digit, or an underscore or a $sign. So we can say name, and then we can put underscore, we can put test, and then the $sign. That's a valid variable name. We can test it one more time right there, and it works. But if we tried something like name and then provided an asterisk, that's not going to work. We cannot use special characters in naming our variables. That's it. So let's go back to the name. Let's just console log the name. Okay, it works. To recap, there are three different ways to make or declare a variable. There's var, let me write that here. Var, there's also let, so let me write that here real quickly. And there's the const, which we have right there. From now on, whenever we are creating variables, we are going to use either const or the let keyword. Const when variable is going to be constant, or let when we plan on changing it later on. Also, a quick question for you. Which rule of variable naming did we break right here? Try to answer it right now. Of course, we named three variables the same thing, so we get the error identifier name has already been declared. That means we cannot have multiple of the same variable names. Let's move on to the data types to see what kind of data can we store inside of our variables. In the previous lecture, we mentioned that we can store values in variables, and that these values need to be in form of one of the predefined data types. The concept of a value is somewhat abstract, especially to someone doing programming for the first time, but we're going to go through it together, nothing to worry about. As we mentioned, there are a few types of values called data types. Let's go through them one by one, and then we're going to explain each one in detail. We can separate data types of current JavaScript standard in two groups. Strings, numbers, booleans, null, undefined, and symbol are considered primitive data types. And only objects are considered complex data types. So as you can see right there, strings are going to be any textual values. Hello everyone, I'm glad that you're here is one. We can also put hello or the whole sentences or paragraphs. Those are strings. Numbers are, as you can see, 5, 6, 7. It could be 1, it could be 10. It can be any decimal value or any whole number. Booleans are true or false. So Boolean type contains only two values. It can be either true or false. Null is only null, which is weird enough, but we're going to see use cases of that soon. And then undefined is undefined. Null specifies that we have something to store value in, but that value is simply non-existent. And undefined means that we don't have either the variable or the value. It's basically undefined, it doesn't exist. Then we have the symbols. We are not going to go through them a lot, they're extremely rarely used. And then the objects. Object is the most important data type, and it is one of the most important building blocks for modern JavaScript. Now, in next few videos, we are going to explore each one of these data types one by one in a separate video. In the following lessons, we are going to use a lot of comments. A comment is text in the code which is not read while we are running the code. Comments make your code easier to read and understand. They can help you and others to read your code. There are two types of comments, multi-line and single line. So in here, I'm going to create a single line comment, ironically saying single line comment, which explains that below this code, we are going to explain how we're going to write single line comments. In a single line comment, anything that follows the two / characters, as you can see, //. So anything that follows these characters will not be processed by JavaScript interpreter. Single line comments are often used for short descriptions of what the code is doing. So right now we can just say test, or we can say this is a single line comment, just like that. Now let's do a multi-line comment. Multi-line comment starts with a / sign. Then we can spread on however multiple lines we want, and then we do asterisk and then /. Anything in between those characters is going to be considered a comment and is not going to be processed by JavaScript interpreter. For example, we can say this is a multi-line comment, just like that. As you can see, this is grayed out and is not real code. This is just a comment to make our code more readable. Multi-line comments are often used for descriptions of how script works. To practice creating comments, we can delete this and then document what we learned about variables in the few previous videos. So I'm going to create a single line comment and say creating a variable using var keyword, just like that. And in there, then we can say var, let's say variable name is going to be equal to test. That's it. We just created a variable using var keyword, and as you can see, your comment clearly explains that. Now we can copy this by selecting it, right-clicking it, and then clicking copy, or we can just say Command C and then Command V, or Control C and Control V if you're on Windows. So right now we can say creating a variable using let keyword, and then in there we can say let variable name. Of course, we can console log it later. So console log variable name. Great. And as you know, this is going to give us an error. So what we can do is we can also just comment this. What you'll often see me doing is I'm going to comment or uncomment something without actually typing 2 forward slashes. You can do that in Visual Studio Code by pressing Command and then /, or it's Control / on Windows. That simply comments the line. That's it. You can also do that on multiple lines. So if I were to comment this and then press Command /, it's immediately going to comment out everything. In 99.9% of the cases, I'm just going to use single line comments. There's no need to use multi-line since we can just do Command /, which is basically make a multi-line comment using just the forward slashes. So that's it. That Command / or Control / keystroke is really important. You'll remember to use it often. So now, since we got an error, I'm just going to comment this out. That's it. Now you can see we get test. Now we can create the final thing, which is going to be creating a variable using const keyword. Then we can just say const here. Now this is not going to work because you can see we have 2 of the same variable names. But if we comment it out, remember, comments are not interpreted by JavaScript engine. So if we just do this and save, you can see we indeed do get our variable name test, but this time using a const variable. We can also write a few rules of creating variable names. So we can say, for example, variable naming, and then in there we can say first rule is going to be the name should be unique. The second rule should be the name should not be any reserved keyword. And then the third rule is that the name must start with either a character, an underscore, or a $sign. That's it. So these were the comments. If you just keep writing comments in your code, it's going to make your code more readable. Some people say that you don't even need comments because the code you write should be clean enough so that everyone can read it by itself. That logic is good, but while we are just starting to learn how to code, comments are going to greatly help you and everyone who reads your code. Great, now with this short lesson about comments, we can move on to our first data type, which is a string. The first data type we are going to learn is called a string. So I'm going to delete all of this and create a single line comment, which is going to say string. So string is a data type used to represent text. Strings are simply fields of text. That's it. You already wrote some strings. Remember when we did console.log and then in there, what you typed was the actual string. So we said hello world like this. Console.log is a method or a function which prints something to the console. It prints a value, but this value is of a data type string. So you can see in there we have a string. That's great. We can also store this value of a string in a variable. So I'm going to say const example string, and then in there I can do the same thing. Hello world. That's it. And then remember, we can simply say console.log example string, as the example string is the variable name of the variable that holds the value of our string. So you can see right there, we do get hello world. A string in JavaScript, as you can see, must be surrounded by quotes. As you can see in here, we have a opening quote and a closing quote. In JavaScript, there are 3 types of strings: single quotes, double quotes, and backticks. So let's first create a string written with single quotes. We are going to create a new variable, const single quotes. That's just the name of the variable. Remember, this has nothing to do with the actual string. It's just the name. And we are going to make the value of it a single quote. And then in there, we can say hello, for example. That's it. We've just created a string with single quotes. We can console log it, console log, single quotes. And we indeed do get the value of a string. Let's do a second example with the double quotes. Const double quotes. Again, this is just the name of the variable, has nothing to do with the actual way of creating a string. And we make it equal to double quotes, and then we can say basically the same thing, but we're going to add 2 exclamation marks, for example. That's it. To see the value, we just need to specify the variable name inside of the console log. That's going to print it to the console. In there, you can see we get hello with 2 exclamation marks. That's it. You just created two different variables using strings in two different ways. But you may be thinking, what's the difference? What's the difference between the single quote string and a double quote string? There is absolutely no difference. They are identical. Double and single quotes are also called simple strings. They are not complex strings. We also have something known as backticks. So I'm going to call a variable backticks. So how do we create something known as a complex string or backtick string? We put backticks. As you can see, it's almost the same as single quotes, but it's angled to the right side a bit. That should be the key left of the one key on your keyboard. Try it out. If you cannot find it, try Googling for backticks for your specific keyboard. Then in there, let's say hello, and then let's say 3 exclamation marks, just so we can see the difference. Again, we get absolutely the same thing, hello with 3 exclamation marks. So why is it a complex string? What's so special about the third way of creating a string? Backticks provide extended functionality. They allow us to embed variables and expressions into a string by wrapping them into $sign and then curly braces. I'm going to comment out these 2 lines and I'm going to create a new variable, const called name, for example. In this case, name is going to be, let's say, Jane. So what do we do with this variable name? Of course, we can console log it just so we can see what name is. As you can see, we do get Jane. But how do we embed the variable name inside of the backtick string? Well, as we mentioned, we can use the $sign and then curly braces syntax. As you can see, this changed color, and then that means that anything that's put in between the curly braces is going to be executed as real JavaScript. So if you put name in there, we are not going to get hello name, we are going to get hello Jane. To test that out, let's just console log the backticks, which should now include the name. As you can see, we do get hello Jane. This is a convenient syntax that allows us to embed different variables into strings. So when would we use this, for example? Let's say that the user is logging in and he's going to enter his name, for example, John, Jane, or anything else. He's going to input his name via a field. We just hard-coded the value here, but this is going to be coming from a field. And let's say his name is John. We're going to say, hello, John, and let's say, welcome. And as you can see, we got hello, John, welcome. But let's say that some other user enters, her name is Jane, and we got hello, Jane, welcome. This is really useful. So let me ask you a quick question. If we have an empty backtick string, and in there we say 2 + 2, and if we simply console log backticks, what do you think the output of this code is going to be? We save it, and you can see 2 + 2 as a string. But how would we make this into 4? How would we make JavaScript know that we need to interpret this as JavaScript logic and not a string? Remember, we put it into $sign and then wrap it in curly braces. Once we do that, we can get 4. That's it. So when should we use single quotes, when double quotes, and when backticks? You can use single or double quotes whenever. So whenever you have just a name or just a static value in there, you can choose between single and double quotes. Sometimes I'm going to use single quotes, sometimes double, but you can stick with just one. For example, just hello there. Whenever you want to do something dynamic, then you switch to backticks. So then you switch to this little backtick syntax. That's it. It's really important to note regarding data types that we can inspect the type of each value by writing type of before the value. So in here, we can write type of and then backticks. This is actually going to give us a data type of that actual value. So you can see that the type of backticks is a string and the type of single quotes is also a string. So there's absolutely no difference between those two approaches. Again, use single or double quotes whenever, and then use backticks only when you want to apply some extended functionality. The second data type on our list are numbers. JavaScript is really friendly when it comes to numbers because you don't have to specify the type of the number. We call this behavior untyped. JavaScript is untyped because determining whether a number is an integer or a decimal is taken care by the language's runtime environment. For example, In traditional programming languages like C, we'd have to declare the type of the number we'd like to use like this. Int whole number would be 5. And then if we wanted to use a float or a decimal number, we would have to say float. So we have to declare a different type of the number for 5, which is a whole number, and float for a decimal number, for example, 0.5. In JavaScript, we can just use plain old const or let and use any number we'd like. For example, we can say const whole number, make it equal to 5, or we can use const decimal number and make it equal to 0.5, for example. We just learned that the number type represents both integers, which are whole numbers, and floats, which are decimal numbers. That's great. JavaScript makes it easy on us. Let's console log those numbers. So let's say console log whole number, and also let's console log the decimal number. Decimal number, just like that. Great. As you can see, we get 5 and 0.5. We can change it to 5555, for example. We can have really large numbers. We can say 10. We can really do anything we want. And you can put this as small as 0.33333 or really anything you'd like. JavaScript doesn't care. As long as it's a number, you can declare it as a normal variable. There are many operations for numbers. For example, multiplication, division, addition, subtraction, and so on. So let's try to do some of them. In here, I'm going to create a const, let's say number, let's say first number. First number is going to be 5. And then let's say const second number is going to be, let's do 10. Great. In there, we are going to create a new constant, which is going to be a result. So we just created a constant variable with a variable name result. In there, we'll play with operations a bit. So let's try first number plus second number to see what do we get. And of course, to see the result, we need to console log result. And then again, Command or Control S to save it, to see it in the console. We get 15. Great. Let's try minus. We get -5. That means that JavaScript numbers work with negative values as well. We can also try some multiplication right there. We get 50, or we can try to divide it. We get 0.5. As you can see, it immediately turned it from a whole number down to the float or the decimal number. We're going to learn much more about many different operations for numbers, string, and so on after the data types video. So immediately after this section, the operations will come. When we try to do some operations with values that are not numbers, most often we will get a nan. So what is a nan? Let's see. If we try doing, let's say a string, so let's make this first number, let's say just a string. So if we try creating a string, which is going to say hello, and if we try dividing that string by second number, let's see what do we get. We get nan, as you can see in the console. This means not a number. It represents a computational error. It is a result of an incorrect or an undefined mathematical operation. If we bring this back to where we had the first number, so where we had a normal operation, what do you think we would get if we do type of and then let's say result? Of course, it's going to be a number because number is a valid data type in JavaScript. But now there is a trick question. It's a really stupid thing in JavaScript. What if we brought this back to where we had a string, for example, hello, and we divide that string with a number? Remember, if we take the value of this, we're going to get nan. So the question is, what do you think the result of type of nan is going to be? The type of nan, which stands for not a number, surprisingly, is a number. The reason for this is, in computing, nan is actually technically a numeric data type. However, it is a numeric data type whose values cannot be represented using actual numbers. Don't overthink this too much. Numbers are quite straightforward in JavaScript. Let's move on to Booleans. The third one on our list of data types are Booleans. So let me write that down. Booleans. Booleans represent a logical entity and can only have two values. It can only be true or false. That's it. It doesn't have numbers like 1, 2, 3 to infinity, or strings, we can keep adding values to strings, create as many different strings we want. Booleans only have two possible values, true or false. That's it. As you'll come to know, these are important values when it comes to adding logic to our programs. With just two values, you can create a complex system of loops and conditions. This type is commonly used to store yes or no values. True means yes, correct, or something like that. It's also sometimes known as 1. So true or 1 means yes or correct. And then of course false is no, incorrect, and it's represented by 0 sometimes. That's it. Let me give you an example of a Boolean. So let's create a variable called const is cool. This variable is going to say if a person is cool or not. And we are going to set it to true at the beginning. That's it. The person is cool. True means yes, correct. Something is correct. That's it. So if we were to console log is cool, what do you think we would get? Well, we get true, right? And then we can test it off with type of is cool, and we do get Boolean. That means that it's a standard data type. But let me show you something cool we can do with Booleans. We can create if statements. Of course, we still didn't learn if statements, but I'm going to just show you this cool little example, which we're going to learn later on. So we can say const, and then in the condition, we're going to put this Boolean. So if the condition in here is true, then we are going to render this code, which we have below. And then in there, I'm going to say console log and something like, hi man, you're cool. Oh, and notice this little thing. Since you created a string with a single quote, this little quotation mark threw us out of the string. That's not great. So what we can do is we can exchange this for a double quote and we should be good to go. Great. Now we can also add an else and we can say console log, let's say, oh, hi, that's it. The person is not cool. So if we do that and save, what do you think? Which console log are we going to see? Since is cool is true, this if statement runs and we get only the console log, hi man, you're cool. But if we switch this to false, you're going to see, oh, hi, which means that we have Boolean false, and in here we didn't enter this if statement. As you can see, this is just a simple example, but in here we have some logic. So depending on many different Booleans, we'll be able to create complex systems. Boolean values also come as a result of comparisons. So what do I mean when I say that? Let's say that we have an age. So a variable, a number variable called age, and we're going to set it to 20. Console.log age, and we can say larger than 20. So is the age larger than 20? Notice how I said in my head is something. Yes, it is, right? Yes means true. So whenever you're asking yourself question, is this larger than 20 or is it not? Let's do 19 just to make sure. So is age, which represents 20, larger than 18? True. Yeah, it's correct. So as you may assume, this is going to return Boolean true. So you can see a number in comparison with some other number returns true. We can also make is lower than, and we are going to get false. That's it when it comes to Booleans. The next two data types on our list are null and undefined. We are going to cover both of them in one video because we need to compare the differences, and also they share a lot of similarities, so we are going to explain what those are. The null type has only one value, null. That's it. The special value null does not belong to any of the types described above. It forms a separate type of its own, which contains only the null value. For example, we can say const age is going to be equal to null. Let's try to console.log the age to see what do we get. And we indeed do get the value of null. Null is just a special value which represents nothing, empty, or simply value unknown. The code above states that the age is unknown or empty for some reason. For example, we can initially set the value of age to be null because we don't know it yet, so we can say let, And then we are going to change it when, for example, user types something in the input. So we're going to have an input of type number, which is going to correspond to age. And then he's going to set the age to be, for example, 20. So right now, if we test it out, we get 20. But at first we initialized it to null because at the beginning we didn't know the value of the age. That's it. Now let's talk about the value of undefined. A variable that has not been assigned a value is undefined. The meaning of undefined is value is not assigned. If a variable is declared but not assigned, then its value is undefined by default. So what does that mean? Let's create a variable called let x, for example, and let's do nothing on the right side. So we are not going to assign any value to it. Now we can console log x, and let's see what value do we get. As you can see, we get a undefined data type or undefined value. Technically, it is possible to assign an undefined value to any variable. So we can as well say let x is going to be equal to undefined, which is basically the same. I wouldn't recommend doing that. Normally, we use null to assign empty or unknown value to a variable, and we use undefined for checks like seeing if a variable has been assigned. So usually, if you want to have undefined, you can just do it like this. That's it. Just declare it without assigning a variable. And if you want to declare it and say that it's empty, then you use null. Many times, we often get confused on what's the difference between undefined and null. Undefined means a variable has been declared, but has not yet been assigned a value, as you can see right there. On the other hand, null is an assignment value. It can be assigned to a variable as a representation of no value. As you can see here, we are setting the age to be equal to null. Unassigned variables are initialized by JavaScript with a default value of undefined. That's exactly why we get undefined here. JavaScript never sets a value to null. You must do that yourself. Let's test these values with a type of operator. So in here, we can say type of x, which is going to be undefined. And if we try doing type of undefined, we are going to get back undefined because that's a proper data type. So what do you think we are going to get if we put this console log right here and test for the value of age? Let's do that. And as you can see, we get back object. So that is really weird because we said that the null is one of the basic primitive data types. So definitely a data type of age, which we set to null here, should be null, right? We can also test the type of null itself, and we also get an object. It's interesting to see that this is actually a bug in the whole JavaScript language. This bug was created before, but now so many, all the world's programs written in JavaScript depend on this little bug. And if we were to fix this, many different code bases which are old would completely break and we would get so many errors. So JavaScript community actually decided to leave this error as a part of the official JavaScript language, which is crazy, but it kind of works. So just remember, the type of null is actually object, which is weird, but that's just how it is. Great, now that we are done with null and undefined, in the next video, we're going to explain objects. In this video, we are going to talk about the data type of objects. Object is the most important data type and it forms the building block of modern JavaScript. The object type is special. All other types are called primitive because their values can contain only a single thing. You can see that a string can contain only one specific string. You can see that the number can contain only one number at a time. Boolean can also contain one value, null also one value, and so on. In contrast, objects are used to store collections of data and more complex entities. What I'm going to let you know for now is that objects in their simplest form are used to group variables. For example, we can create a variable of name and age. Const name is going to be equal to John and const age is going to be equal to 25. These variables in the current state are in no way related one to another. We can create an object called person and put them together. So how would we do that? We can create an object by doing the same thing as we do with all other variables, const, and then the variable name, in this case person, and in here we create an object with a pair of curly braces, just like this. Inside of there, we can specify properties or variables. So in here, we're going to say name, colon, and then in here, we're going to say John. And below, we can also put age of 25. As you can see, the syntax is a bit different. In here, we have a key and a value, name and John, and the age 25. Now, we know that both name and age belong to the same entity, the person. That is an object. As you can see, we declare the same way as all other variables and then put curly brackets inside of which goes the data. The one last thing that we can mention is that we can now extract specific values from that object using the dot notation. So how would we get the values? Well, we can first console log the entire person, and we don't need this standalone variables anymore. We just have the person object, and let's see what do we get. As you can see, in between the brackets, we get the name of John and age of 25. So how can we get a specific value? For example, just the name. Well, we use the dot notation. Dot notation. As you may assume, we use person and then put a dot and then take the name property. So person.dot is going to give us a string of John. So let's say that we want to test the type of person. That's going to give us an object. You can see we do get an object. But if we were to do the type of the person.name, you can see that name is a primitive data type of a string. So we are going to get string. That means that the person or an object can contain any data types inside of it. It can contain strings and it can also contain numbers. There are many other kinds of objects in JavaScript. We have arrays to store ordered data collections. For example, an array would be const array, and in there we can store something like, let's say 1, 2, 3, 4. In an array, we can store multiple primitive types, but in here we don't have keys and the values. We just have indexes. So this is 0, 1, 2, 3, and so on. But again, we're going to learn about arrays more specifically later on. Let's console log that array to see what do we get. As you can see, we get 1, 2, 3, 4 in an array, and we have indexes of 0, 1, 2, 3. We also have something known as a date object. If we tested const date, which is going to be equal to new date, let's see what that gives us. Let's console log that date. Console log, and then in there date. As you can see, we get this complex thing, which gives you the current date and time. That's also an object. Sometimes people just say array or date type, but formally they are not types of their own. They belong to a single object data type, and they extend it in various ways. So this array, if we test the type of the array, so type of array, we should get indeed an object, as we do with just the person here, object. And if we test a type of date, you can see that it is an object. That's all that I'm going to let you know for now. Objects are complex concepts. First, let's master the easy things, and then we can get back to objects in one of the later videos. We just went through all of the data types. There's only one more thing I'd like to let you know. In general programming, when it comes to data types, there are two types of programming languages: statically typed or dynamically typed languages. So we have statically typed languages and dynamically typed languages. What does this mean? Statically typed languages are languages where each variable and expression type is already known at compile time. So once a variable is declared to be of a certain type, it cannot hold values of any other data type. That's the case in C, C++, or Java. For example, in C, if you declare a variable to be a number, you have to say int, which stands for integer. So int number. is going to be 5. You cannot do number is going to be like a string of test now. This is an error. If you declare a variable as a number, it must stay a number. On the other hand, we have dynamically typed languages. They can receive different data types over time. JavaScript is dynamically typed. That means that variables in JavaScript can receive different data types over time. We are going to see this in action really soon. A variable in JavaScript can contain any data. A variable can at one moment be a string and at another one be a number, for example. So let's declare a variable called message. So we're going to say let message, and we're going to make it equal to hello world, just like that. Now let's console log that, console log the message, and as you can see, we get hello world. We can also console log the type of the message, and we do get a string. So now what would happen if we said message is going to be equal to 5? So we redeclare the value of a variable to be 5. Now let's do the same thing. I'm going to run another console log down there to see what the message is going to be. And as you can see, first the data type of the message is string. And then if we also ask for a data type here, then it's changed to number. A variable in JavaScript can at one moment be a string and at another one a number. Again, we don't have to just change it from a string to a number. We can change it, for example, to, let's say, Boolean. So we're going to do true. That's also viable. So we can start with a variable which is a string, and then at the end it can be a Boolean. It doesn't really matter. This is a completely valid syntax. So the only thing that you need to remember here is that JavaScript is dynamically typed, which means that at one moment the variable can be a number, for example, and then if it's a let, of course, we can change that variable to be a string or anything else. That's it. Great, that's it for this video. The next type of operators on our list are comparison operators, and in here we are also going to cover the concept of equality in JavaScript. As you already heard of the arithmetic operators, the same goes for comparison operators. That's it. These are the comparison operators. Comparison operators compare two values and return Boolean value true or false. Let's write that down. Comparison operators, and then return either true or false. That sentence is the main takeaway. If you understand that, you're good to go. The return value of a comparison operator is always going to be a Boolean value. The topic of equality in JavaScript is closely connected to the comparison operators. I've got you covered there as well. We are going to go through both topics in this video. So let's start. Let's say we have two numbers. Const A is going to be equal to 5 and const B is going to be equal to 10, the same as in last video. First, we are going to learn how to test whether a value is greater than the other value. We can do that by doing console.log, and then A is larger than B. That's it. Just a simple console log. In here we have A, then we have a comparison operator greater than, and then we have B. If we test that out, as you can see, we are always going to get a Boolean value, either true or false. In this case, we get false because A is not greater than B. We can also test whether a value is greater than or equal to. For that, you just put a equal sign immediately next to the greater than sign. For me, it merges them together, but it's completely the same thing. So if I do that, we are still going to get false, but right now, if I make A to be equal to 10 as well, you can see it's true because they are the same, but in here we have the equality as well. If we make this 11, it's still going to be true, and if we make it 9, it's not going to be true anymore. So let's bring this back to 5, and we are also going to keep all of them in the comments. So in here I'm going to say greater than, also greater than or equal to, and that's the one that we have right below. Greater than is of course just the greater than sign without the equal to sign. That's it. Then we can also test whether a value is less than other value, so less than, and we are going to do a console log. In there, A is less than B. That's it. Just a sign that's completely opposite of this one. If you cannot find these signs on your keyboard, just feel free to Google less than or greater than signs on your specific keyboard. That's it. So less than, and that's going to be true. But let's just comment out these console logs so they don't cause any interruptions. In here, we get only true because 5 is indeed less than 10. That's it. Let's also comment that one, and let's do less than or equal to. So what do you think? How are we going to do that? Well, we're just going to add less than and then the equal sign next to it, just like this. Again, for me, it ties them together, but it's absolutely the same thing. If we test that out, again, we're going to get true. If we make them equal, so 10 and 10, we get true. But right now, if we try that the same thing, 10 and 10, with just the less than, it's not going to be true. It's false. Because A is not lower than B, they are equal. But if you do less than or equal to with the equal operator, that's going to be true as well. Finally, now we have the equality operators. We can test whether a value is equal. So we can say is equal. How do we do that? Again, in the console log, we're going to test it out. We're going to see whether A is going to be equal to B. Remember, we do one equal sign when we want to assign a variable. We're going to learn about the assignment operator later on. And then we want to do two equal signs when we want to check whether a value is equal. So if we test that out, because now they're both 10, we are indeed going to get true. The thing that we can test next are whether values are not equal. So I'm going to do a new line, new comment, say not equal. And then in there, we're going to create a console log like this. So how do you say something is not something? Not. In programming, for not, no, negation, something like that, we always use the exclamation point, just like this. So we're going to say A exclamation point equal sign B. Again, it turns into something different for me, but that's just exclamation mark and then the equal sign tied together. That's it. So A is not equal to B. That's what we are testing, whether they are not equal. Remember, all comparison operators and equality operators, this one here, return Boolean values, either true or false. And we are testing whether A and B are not equal. A and B in our case are both 10, so they are equal, and this returns false. If we try changing this to 5, they are now not equal, and it's going to return true. What you're going to see more often are going to be strict equality and strict inequality operators. They look like this. So I'm going to write strict equality and then strict inequality. So inequality, just like that. So for strict equality, we do console.log, and it's absolutely the same thing as above, A, but in this case, we don't have double equal sign, we have triple equal sign. So this is a strict equality. In JavaScript, you're going to see people do this much more often than this. We're going to explain exactly why in the next video. In the same way, we do the strict inequality, but instead of the 3 equal signs, we do first not sign, exclamation mark, and then double equal sign. This is going to say whether values are strictly not equal. So you can see A is not equal to B, we do get true, and that's because our A and B were 5 and 10, which are not equal. If we try 10 and 10, you see we get false. Great, everything we've covered so far is pretty straightforward. The only thing I'd like to take a deeper look at is the strict versus loose equality. What are the differences and when should we use each option? Let's cover that in the next lesson. In this video, we are going to talk about concepts of strict versus loose equality in JavaScript. Equality is a fundamental concept in JavaScript. We say two values are equal when they have the same value. So if I scroll down there, we can again play with some console logs. So if I say console log, and then in there, let's say that we have a value of 5. We can say, as we learned, double equal to 5. These two values are indeed equal. We can also check whether two strings are equal. So for example, if I create a string called hello, and if I make it equal to another string called hello, just like that, we get true and true. We can also switch these to strict equality with triple equal signs, and we do get true, true one more time. Note that we use 3 equal signs to represent this concept of equality in JavaScript. JavaScript allows us to also test loose equality. It is written using 2 equal signs. Things may be considered loosely equal, even if they refer to different values that look similar. An example would be the following. In here, let's say that instead of 2 number 5s, we have a 5, and then we have a string that has a number 5 in it. So remember, this is not a number, although it may look like a number. This is a string. And if we now test that with double equality, we get true, which is extremely weird because those two values shouldn't be the same. This is the number and this is a string. With triple equal sign or with strict equality, we get false. And that's how it should be. Let's explore both loose equality and strict equality in more detail. First, we're going to talk about strict equality. The strict equality method of comparison is a preferred option to use because its behavior can be easily predicted, which leads to less bugs and unexpected results. The JavaScript interpreter compares the values as well as their types and only returns true when both are the same. So let's write that down. Compares values and types. We can say data types, right? Because we learned about that. Compares values and data types. Returns true only if both are the same. So it compares both values and data types. If we try doing a console log, inside of which we have a value of 20, for example, and we want to check the strict equality with a string of 20. This is going to be false because even though the values seem to be the same, they are of different types. The first one is of type string and the second one is of a type number. We write loose equality using double equal sign. So again, if we take the example from the strict equality, console.log, and then we do 20 is going to be equal to double equal sign because loose equality. To the string of 20, we are going to get true. It does the same underlying logic as the strict equality, except for a minor yet huge difference. The loose equality doesn't compare data types. So let's write that here. Doesn't compare data types. You should almost never use the loose equality. Douglas Crockford, in his excellent book called JavaScript: The Good Parts, wrote, JavaScript has 2 sets of equality operators. The good ones, so let's write that there, the good ones, which are going to be triple equal and not, strict not equal. And then we have the evil twins, which are going to be loose equal and loose not equal. The good ones work the way you would expect. If the two operands are of the same type and have the same value, then strict equality produces true and strict inequality produces false. The evil twins do the right thing when the operands are of the same type, but if they are of different types, they attempt to change the values. The rules by which they do that are complicated and unmemorable. These are some of the interesting cases which could cause errors in your applications. So let's see. We're going to have an empty string and a string with a 0 in it. And then we have the loose equality. What do you think we are going to get? Before we save it, we're going to remove this console log. And let's save it. As you can see, we get false because this is not correct. But what if we did something like 0, which is not a string, and then compare that to an empty string, which is a string that doesn't have anything in it. So we said this is false, and if we save this, we get true. Like, how can we even get true with these two values? That doesn't make any sense. Let's test with something else. So let's do console log, and then 0 is going to be equal to a string of 0. Again, with loose equality, let's test it out. We should get true. Yeah, we do get true. Also weird, shouldn't happen. Let's test a few more examples. Console log, and then in there, let's do false, which is a Boolean, and compare that to false, just a basic string that includes false. Do you think this is going to be true or false? Try to answer with me. Let's test it out. We get false. Again, doesn't make any sense. You might have said it's going to be true, but it returned false, which is again weird. Let's try one more thing. So let's do false is going to be equal to, let me just uncomment this. So Boolean of false is going to be equal to a string of 0. Oops, for some reason it returns true. There are hundreds more examples where the evil twins produce unexpected results. That's not good, and that could cause errors. So let me just show you a few final tests, and then we can repeat what we learned. Let's do console log. True is going to be double equal to 1. We talked about the Boolean value of true, right? We said, yeah, that means like something is true, something is correct, and we can also say that's 1 opposed to 0. With the loose equality, if we save that, we indeed do get true. But again, we said this is a data type of Boolean and this is a data type of number. They shouldn't be the same. But the true gets converted to 1 and then it compares it. What if we try doing again the same thing, a string of 5 with a number of 5, we also get true, even though they're not of the same data type. That happens because the string of 5 is converted to the number of 5 and then compared. But if we switch to using the strict equality, as we always should, we get false, false, because these two values are not the same and they should never be. With loose equality, both of these are equal, and that should never happen. 5 is a string and should be treated like that. As I mentioned, most of the JavaScript developers completely avoid loose equality and rely only on the strict equality. It is considered a better practice and it causes less bugs. From now on, you're going to see me only use the strict equality. And for the end, I found for you a great visual representation of strict versus loose equality. In here, we have a table, and in the table, you can see on the top row, we have some values, true, false, 1, 0, -1, and so on. And we have them in the column as well. And in here, each dot tries to compare, with double equal currently, the value from the row to the value from the column. True, when compared to true, is going to be true, correct? That's with the double sign. As you can see, with loose equality, we get these green boxes all over the place. They are unpredictable. But if we switch to strict equality, right there at the top, we get this nice predictable line. So, what's the moral of the story? Right there at the bottom corner. Always use triple equal sign or strict equality. The next type of operators on our list are called logical operators. Logical operators, just like that. JavaScript includes 3 logical operators, so let's write them here. It's a logical operator OR, we have the AND we have the NOT. So how do we write each one and what does it mean? Complete knowledge of logical operators requires the knowledge of if-else statements and true and false values. In this video, we're just going to cover the syntax of logical operators, and then we're going to come back to them to see them in full action after we cover the 2 mentioned topics. To write the AND operator, we use the double ampersand syntax. If you don't know where this is on your keyboard, feel free to Google it, but that's the double ampersand. So, how does the AND operator work? It checks whether all operands, so I'm going to write that down, all operands are true. And if they are, it returns true. Simple as that, returns true. If they are not, it returns false. So how can we see that in action? Let's write a console log, and then in there, we're going to have a true Boolean value, and we're going to use the AND operator. In there, let's try it with a false. So we are saying true and false. What do you think this is going to return? In here, we learned that the logical AND operator needs all values to be true for it to return true, and otherwise it returns false. In here, we have true, but we indeed do have false as well. So not all operands are true, and because of that, in the console, we get false. If we convert this to true, you can see now all of the operands are true, and we are going to get true. Also, if we check for two false values, of course, the value is going to be false. That's it. We can also pass multiple conditions. So let's try with, for example, true, false, and then we can say and true. What do you think the output of this is going to be? True, false, true. All operands need to be true. In this case, false is not true. So even if one single one is not true, it's going to return false, as you can see in the console. If we switch this back to true, then we have a true value. Now we can move on to the second operator, and it's the OR operator. We write the OR operator with a double straight line. Again, if you don't know where to find it on your keyboard, feel free to Google. That's the double straight line. Right now, we can test it out. So we're going to do the console log and then say true or false. So how does the OR operator work? It checks whether at least one operand is true. So let's say at least one operand is true, and then it returns true. So opposed to the AND operator, where all operands need to be true for the output to be true, with the OR operator, we need at least one of the operands to be true for the entire thing to be true. So in here we have true and false, which is going to return, what do you think? True, because we have one true value, and that's all that the operator needs. What if we did true and true, for example, just like that? That's also true, because at least one needs to be true, but we can just have all of them as well. And then, as you may suppose, with two false values, this is going to be false. The final operator is called a NOT operator. And we've already seen this one when we did the equality. Remember when I said this is not equal, not the exclamation mark? That's it. So we write not with the exclamation mark. All that it does is it reverses the Boolean value. So if we have a true value and then we add an exclamation mark or not operator at the start, we are basically saying not true, which is going to return false. That's it. And then if we say not false, you can guess it, it returns true. As you can see, the not operator simply converts the Boolean true to false and Boolean false to true. That's it. This was just the introductory video to these logical operators. They are used really often in real JavaScript applications, and I'm excited to show you their real uses once we learn about if statements and true and falsy values. Hi everyone, and welcome to another section of the course. This one is quite a big one. In this section, we are going to use everything we learned so far. Data types, variables, operators, equalities. We're going to make conditions. As you can see it on the slide, we are going to make decision-making code using if statements, true and falsy values, switch statements, and ternary operator. We are going to make conditions, and based on those conditions, our code is going to run differently. In here, we are going to, for the first time, see blocks of code. Many interesting things coming up. Stay tuned and see you in the next video. You might have read the title of the current section, Logic and Control Flow, and you might have wondered, what does that mean? It's much simpler than what it may seem. In every programming language, we have something known as an if statement. If statement is consisted of a condition that is evaluated to either true or false and a block of code. That's it. If the condition is evaluated to true, then the code inside of the block will run, otherwise it's going to be skipped. That's it. We can jump back to the Visual Studio Code. Right now I am in the section 04 Logic and Control Flow. You can create your own new files, or you can just use existing ones. If statements often appear in terms of some rules or laws. Let's say that there's a nightclub that only allows people over the age of 18 to enter. And now we are, for the first time ever, using variables and code to create something useful. So in here, we are going to say age is 18. So we get age from a random person, and there we can set an if statement. This if statement is going to be the guard or the bouncer for our club. If statement is written like this. We have a if keyword, then we have parentheses in which goes the condition. So I'm going to say condition right now. This is not real code. This is just what needs to go in there. And then in here, we have the block of code. So for the first time ever, you can see curly braces and parentheses used like this. This is a reserved JavaScript keyword, if. Then, as we mentioned, we have a condition, and then we have the block of code to be executed if this condition turns out to be true. So inside of here, we can use the age variable and use one of the comparison operators to get a Boolean value. So let's say that the age must be larger than 18, just like this. And in here, we can write just a simple console log, which is going to say, you may enter. That's it. If we save that, do you think we are going to see the console log in the console? Let's save it. And we cannot see nothing, unfortunately. Why is that? Well, that's because our age variable is exactly 18. To enter the club, you need to be above 18. So we're just going to make it more than or equal to 18. If we save this, you can see we get the console log of you may enter. Great. If statements also have an else if and else statements. To continue with our example, let's say that our person currently cannot enter because his age is exactly 18. So just like this. Then you can provide an else if statement. This is exactly like our initial if statement, only it's the second if right now. They are chained together. So in here we have else if. So if this condition turns out to be false, then it's going to check for this condition right there. And in here, let's say whether age is going to be equal to 18. So exactly equal to 18. If that's the case, we are going to say console.log. You just turned 18. Welcome. That's it. So just like that, let's save it and see. Okay, our person just turned out to be 18 and we got a console log right there. As you can see, the first condition, the result of this comparison, turned out to be false. So this block of code wasn't executed. Then we had a second condition, else if right there, if age is exactly 18, which is true in this case, and then we got this console log. But what if the person is younger than 18? We currently aren't handling that case. That's where the else statement comes in handy. We implement it like this. Else, and then immediately a block of code without parentheses for condition. It's just else. Why don't we have a condition besides it? Well, if no other condition turns out to be true, then this one is going to be executed for sure. It doesn't need a condition. In here, let's say console log, and then let's do something funny like grow up, exclamation mark. That's it. So right now, we always get age 18. But what if we change the age? So now the only thing that we have to do is change the age variable to get the different console log. So let's say 24, for example, not 124, just 24. And we save it and we get you may enter because the age is more than 18. If we change it to, for example, 15, a little boy trying to enter the club, we get grow up. That's it. And if we make it exactly 18, we get you just turned 18. That's it. On this little example, you just learned one of the key concepts of all programming languages. Congrats. Sometimes we want to repeat a specific action a certain number of times. For example, let's imagine we want to display numbers from 0 to 9 in the console. You might be thinking of doing something like this. Console.log, and then in there we console log 0. Then we copy it, and then we console log 1, and we keep moving forwards with new lines of code to console log numbers from 5, 6, 7, 8, and finally 9. If we save this, as you can see, we get 9 different console logs with numbers ranging from 0 to 9. But take a look at this. this is quite repetitive. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 characters per line which are being repeated. And there's only one thing that is changing, that specific number. So 14 characters repeating just to change one single thing. That's not a good idea at all. So instead, we can use a for or a while loop. Let me show you how to do that. The while loop has the following syntax. It looks like this. While, in there we have opening and closing parenthesis, in there goes the condition. Then we open a block of code, and this is where we type in our code. While the condition is truthy or true, the code from the loop will be executed. For instance, let's do the same thing we had previously with a while loop. For that, we have to create an external variable. Usually in loops, we use a variable called I. It's short and it works. We declare this variable I to be equal to 0, and now we want to do something in here while I is less than 10. Remember, we want to console log something while I is less than 10. In here, we can put that console log. But what do we want to console log? Well, first time we want to console log 0, the second time 1, and 2, and so on. So what do you say that we simply console log I, and that's it? You might be thinking, well, I is only 0 now, so it's going to be 9 times 0, right? Well, after we console log I, then we can increment it. So we console log 0 and then put it to 1. Then the code is going to be executed one more time because this check is going to check is I now 1 instead of 0, is 1 less than 10? And the answer is yes. So the code is going to be ran again. It's going to console log 1 and then it's going to increment it to 2. In that case, it's going to check is 2 less than 10? The answer is still true, so it's still gonna run it. If we now run this, you can see we get numbers from 0 to 9. The same thing we had before, but you can see how this code looks so much cleaner. Let's talk a bit more about looping. A single execution of the loop body is called an iteration. The loop in this example makes 10 iterations, once for the console log of 0 and the last one for the console log of 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are 10 different iterations. If I++ was missing from the example above, the loop would repeat, in theory, forever. The never-ending loops are called infinite loops, and that's not a good type of a loop, so we never want to get infinite loops. If I deleted this, what's gonna happen is that it's gonna console log 0, and then it's gonna check is 0 less than 10? Well, the answer is true. So it's gonna console log it again. And then it's gonna keep console logging that basically to infinity. Don't save the code that looks like this because your browser is gonna crash and also live server extension with it, and then you won't be able to continue with this lecture normally. So trust me, if that happens, you're gonna run into an infinite loop and we don't want that. Great, now we have only 10 iterations from 0 to 9. The second loop on our list is called the for loop. The for loop is more complex, but it is also the most commonly used loop. It is called a for loop because it runs for specific number of times. For loops are declared with 3 optional expressions separated by semicolons. So let me show you what's the structure. At first, this might intimidate you, but don't worry, you're gonna see it in action and it's going to make sense. You can just type for, put an opening and closing parenthesis, and then open the block of code. Now in here, we have these 3 things we talked about, 3 optional expressions. First one is the initialization followed by a semicolon. Then we have a condition followed by a semicolon again, and then finally we have something known as a final expression. So a lot of things to handle, but let's see it on an example. The initialization statement is executed one time only before the loop starts. It is typically used to define and set up your loop variable. Remember that I variable we had in the while loop? Well, we also have it here. So you can say let I is equal to 0. That is the initialization. The first part before the semicolon. In here, we declare our variable. Then the second thing is the condition. The condition statement is evaluated at the beginning of every loop iteration, and it is going to continue as long as it evaluates to true. When the condition is false at the start of your iteration, the loop will stop executing. This means that if condition starts as false, your loop will never execute. So let's say that I variable is equal to 0, and then in here we have the condition. Let's do the same thing we did before, which is while I is less than 10. That is our condition. So currently, I is less than 10, it is 0, so the loop will execute at least one more time. And then the final expression is executed at end of each loop iteration prior to the next condition check. And it is usually used to increment or decrement your loop counter. Now that we said that, in here we can use the I++ to increment that variable. So what is happening here? Well, first we initialize the variable I to be equal to 0. Then we keep checking if I is less than 10 every time for the iteration, and then at the end of every iteration we increment the variable by 1. Now what we can do is we can say console log and then in there put the variable I. We get the same thing we got with the while loop. I know this is a lot of code, so let's repeat it one more time. First, we initialize our variable I to 0 because we start to count from 0. I stands for index, and it's kind of a standard for loop variable. Next, we set our condition to while I is less than 10. So every time before the loop executes the statement, it will check if the condition is true, or in our example, if variable I is less than 10. If it's equal to or greater than 10, then the condition will evaluate to false and terminate our loop. Final expression is our counter update, and we set it to I++, which is shorthand for I is equal to I+1. For each iteration, I is increased by 1. At the beginning, we said that expressions are optional. That means that we can skip parts. For example, we can initialize loop variable before the loop like this. Let I is equal to 0, and then in here, we don't have to have anything but the semicolon. No need for initialization. Actually, we can remove absolutely everything from the loop, like this, and just have 2 semicolons. But we never want to do this because, as you learned, this would be an infinite loop. So this is not a good practice. And this here, without the initialization in there, is also not a good practice. So you always want to have all of the 3 expressions in there, the initialization, then the condition, and then the final expression. That's it. This is a for loop. And that's it. We learned all the basics of loops. The main thing I want you to take from this video, apart from obviously knowing the syntax for the while and the for loop, is that whenever you find yourself using that repetitive kind of code that we had like this, or it doesn't have to be like this, whenever something is repeating a lot of the times, but only one thing is changing, or only small amount of thing is changing per line, that is a place for a for loop. This is not a good practice in code. There is actually an acronym called Don't Write Dry Code. And then dry stands for don't repeat yourself. So basically, never write dry code, never write code that looks like this. Always use loops if you can optimize your code and make it less repetitive. That's it for this section, and let's move on to the next one. Hello everyone, and welcome to another section of the course. In this section, we are going to talk about functions. Before we start, let's, as we always do, set up our working directory. In here, I have a functions directory with index.html file and a script.js connected right in there, as we did with all the other times. In here, in the script, let's write a simple console log. Let's do test. And if we save this, you should be able to see this on the side. So I just did right click on the index.html and I opened it with live server. Afterwards, I just opened the console in the browser, and that should leave you with the console on the left side and the code on the right side if you set it up that way. Great, now we can close this left side and have just the script open, and I'm really excited to show you how functions work. Functions are one of the most interesting and most important parts of any programming language. So what are functions and why should we use them? A JavaScript function is a block of code designed to perform a particular task. Remember that, a block of code, and it performs a task. That's it, that's a JavaScript function. You've already seen a function in JavaScript. Not only that you've seen it, you've used it multiple times by now. It was the function called console.log. Console.log is a built-in function. We don't have to create it, but we can make use of it. Console.log has a task of printing values to the console. For example, if I in there type print, it's going to print the string of print to the console. After finishing this section, you'll be able to create your own functions as well. Now let's dive right in. When talking about functions, you're often going to hear two terms: a function declaration and a function call. It's extremely important to differentiate these two and to know when should you use each one of these. So let's explain them. Creating a function declaration means that we are defining a function. So this is the step where we define a function, and a function call means that there we are calling or executing a function. So let me put that there, calling or executing a function. So in here, as you can see, we first need to have our function created or declared before we can make a function call. I'm first going to show you an example of a simple function called square. So we create a function, it's called square, it accepts one parameter called number, and then in there we're going to return a number times number, just like that. A lot of stuff happened here. Let's review it word by word. Function is a reserved JavaScript keyword for creating a function. Square is the name of this particular function. You can name your functions anything you'd like, but it just cannot be a reserved JavaScript keyword. For example, function, that's not gonna work, or function var, let's say, or function const. That's not gonna work. You can use any name that's not a reserved JavaScript keyword, just like that. In our case, we are going to call it square because it's gonna square a number. Then, inside of the parentheses, we have something known as parameters. Parameters are values we are going to send to our function when calling it. The function square takes one parameter called number, as you can see right there. Names of the parameters do not matter. You can name them however you like. For example, we could have done x here, and in that case, we would have to multiply the x by x. I know this is all confusing because it's new, but we have a lot of videos explaining how to declare functions, how to make function calls, so by the end of this section, you should have a pretty good understanding of how functions work. Don't worry, we're gonna get through that. So as we said, our square function accepts one parameter called number. That's what we reviewed so far. Then we have an opening curly brace. It represents a start of the function block. Everything else up to the closing curly brace right there represents the function body. In function body, we can write all the things we learned so far about JavaScript. We can create variables, do something with operators, add if-else statements, and so on. This example function is consisted of one statement that says to return the parameter of the function, that is number, multiplied by itself. The return is really important. Every function needs to have it. It specifies the value that will be returned by the function. And how can we retrieve values from functions? We need to call them. Let me explain what do I mean by that. Now we are going to go to the second part, which is a function call, and then in there we'll have to see how we can make a call to that function. Defining a function does not execute it. Defining it simply names the function and specifies what to do when the function is called. That means that in here, when we created this function declaration, or when we defined a function, our code didn't do anything. If I save this, you can see we see nothing in the console. This code wasn't even executed. We can test that if we add a simple console log right there. Console log, and let's do I'm here. If we get this I'm here, that means that our JavaScript code was executed inside of here. Let's save it. And as you can see, we don't get anything. That means that the code that we've written so far wasn't even executed. And that's the thing, that's important to understand. This is just a function declaration. We need to make a function call to actually call or execute the code inside of this function block. So let's see how we can do that. Calling the function actually performs the specified actions with the indicated parameters. For example, if you define the function square, you could call it as follows: square, and then a pair of parentheses. In here, we have the function name, this one, and then we have the parentheses. In parentheses, we put something known as arguments. Arguments are the values we want to fill our parameters with. For example, if we send the value of 5, our parameter called number in the function declaration is going to become the number 5. Then we multiply it by itself and then we return it. As you can see, we now get the I am here console log. It is printed to the console, but for some reason, we don't get the value of 25, right? 5 multiplied by 5. Why is that? Well, we need to make use of that return value of the function. And how do we do that? How do we get the result of this function? Well, we have to store it in a variable. We can do that by creating a variable. In this case, we can call it result. So right there, const result is going to be equal to, and then we're going to assign our function call to it, just like this. What this is going to do is it's going to take the return value of our function. In this case, it's going to be 5 times 5, which is going to be 25, and it's going to assign it to our result. Then we can console log the result to see the final value. Now we can remove this console log, so we just have a clean number times number function. We are calling our function right there, and then we are assigning a result of this function to a variable called result. Finally, we can do a console log as we learned, and then we can print out that result to the console. This is going to store the return value of the function square, called with an argument of 5, to the result variable. Now, if we console log it, we indeed do get the value of 25 right there in the console. This is just an introductory video. We went through quite a lot of stuff in here, so I would advise you to rewatch this video one more time, and the only thing you should really take from this video is to know what a function declaration is, where we define a function, and know what a function call is, where we call or execute the function. Therefore, you need to know that the function declaration is not going to be called, is not going to be executed. We are not going to see any code until we actually make a function call. In the next video, we are going to repeat everything we learned so far about functions, and we are going to go into just a bit more depth about declaring and calling our functions. In this video, we are continuing exactly from where we left off. As we learned in the last video, functions are sub-programs designed to perform a particular task. The code of the function is executed when the function is called. This is known as invoking the function. So as you can see, sometimes it's called a function call, executing a function, invoking the function. These are all buzzwords and synonyms, but they all mean the same thing: calling or executing our function. Let's revisit the process of creating or defining a function, this thing here. There are a few different ways to define a function in JavaScript. There is a function declaration, as you can see right there. It defines a named function. In our case, it is named square. To create a function declaration, you use the function keyword followed by the name of the function. Let's just comment all of this for now, and then we'll write this down below. In here, we are talking about a function declaration. And let's see an example. To create a function declaration, you need to use the function keyword, as we learned, followed by the name of the function. Let's just call it name right there. Then you can also pass some parameters, or let's call them params in this case. And then you can execute a range of different JavaScript statements, just like that. So this was a function declaration. You already learned how to do this. There is also a function expression. A function expression defines a named or anonymous function. An anonymous function is a function that has no name. In this example, we are setting the anonymous function to be equal to a variable. In here, we are using the same old variables we are used to, and we are making it equal to a function expression. So right there, we write a function keyword, we can pass some params in, and there we can do our statements. So this is a different way of declaring a function. You can see in the first way, we have a function, and then we have a name with params. In this case, in a function expression, we have a variable, and then we are setting the value of the variable to be a function expression. And the third way is called an arrow function. So an arrow function expression sometimes, but it's just shortened for an arrow function. So what is an arrow function? Arrow function is a shorter syntax for writing function expressions. It looks like this: const, name of the function, there it accepts params, and then it looks really similar to this, but now you have the statements here. As you can see, all of the three ways of creating a function look basically identical. They have some small differences. You do not have to learn all of them. Arrow functions are the most modern way to create a JavaScript function. For that reason, we're going to explore them in much more detail in the upcoming video. So in 99% of the cases, we'll be using arrow functions. There's only one advantage of using a function declaration, and that is that they have access to this keyword. So when you want to use this keyword, again, more on that much later in the course, then you need to use a function declaration. In all other cases, basically 99.9% of the cases where you don't use this keyword, feel free to use a JavaScript arrow function. It is the most concise and modern way to create a function. Okay, now let's explore a few ways on how we can actually invoke a function. For that, I'm going to comment this out. Feel free to keep that and play with that. Make some function calls maybe to these functions. Change the names, change the parameters, console log something, just so you can see what's happening in there. Now, I'm going to give you a full example of creating a function, and then we're gonna invoke it or call it. Just to repeat, a function is executed only when it is called. This process is also known as invocation. You can invoke a function by referencing the function named, followed by an open and close parentheses. So if we, for example, wanted to invoke this function, this arrow function, the only thing that we would have to do is we want to call the name, because that's the name of the function, and then a set of parentheses. That's it. Okay, I'm going to comment this out because right now we are going to create and test our invocations on real functions. We're going to define a function named say hi. This function will take only one parameter, and it's going to be called name. When the function is executed, the only thing that we want to do is call a console.log, and in there we're going to have backticks, and we're going to say hi, $, curly braces, and then the name. So what's happening here is that we want to console log the hi name, where name is going to be coming as a function parameter. Now, if we save this, nothing is going to happen, as you can see on the right side. But what do we need to do to make this work? We need to invoke, call, or execute our function. To invoke our function, we call it while passing in the name argument. In this case, let's call our function say hi, and let's pass an argument, which is going to be a string of, for example, Joe. That's it. Now, if I save this, in this case, the output is hi Joe. Imagine you have this function connected to a machine that stands in front of a bar, for example. Whenever a user enters his ID, this function is going to greet him by his name. So that's one use case. You could do that with JavaScript potentially. That's great. For example, if we do say hi, and if we enter Jane right there, as you can see, we get hi Joe and hi Jane just by changing this little thing. We don't have to every time repeat ourselves and write the whole console log right there. In this case, we get back the console log, but as you can see, we have no return value. And why is that? Remember when we said that every function needs to have a return statement? This one doesn't have it. This one just console logs something. In the next video, we are going to go into more depth about the return statement in a JavaScript function. Every function in JavaScript returns undefined. So every function returns undefined unless otherwise specified. That means if we don't say what do we want our function to return, it's always going to be undefined. Let's create a function called add. So now we know we can do function, we name it add, and then we have a set of parentheses. There we can enter some of the parameters. In our case, let's just do a and b, which are going to be two numbers. Then we have a pair of curly braces, which means that this is our function body. And then in there, let's just return a plus b. So when calling this function with values of 2 and 2, we're just going to return a plus b, 2 plus 2, and that's gonna be 4. Now we need to call it, of course, because nothing is happening right now. So we can create a new variable called sum, and then we are going to make the sum equal to the function call of this variable, and that's gonna be a and b. And we are going to enter our arguments there, the arguments of 2 plus 2, for example. Now we are currently not doing anything with the sum. To get the value, we need to console log the sum. So in here, I'm going to console log the sum to see what's happening. And as you can see, that's it. We get 4. Awesome. The return statement not only returns values from a function, but it assigns them to whatever called the function right there. In this case, that's sum. Another important rule of the return statement is that it stops the function execution immediately. For example, if just above this return statement, we create a new return statement, which is always going to return a static value of returned. Just like that. As you can see, this return is already grayed out. It's unreachable code detected. So whenever we have multiple return statements, only the first one is going to be executed. As soon as the first return is reached, it immediately goes outside of the function. It goes here, it does the sum, and just keeps on going. It doesn't care about what's happening after something is already returned from the function. So in this case, if we do this, as you can see, we only get returned and nothing else is happening. Okay, consider this. Let's say that we have another function and the function is going to be called test, just like this. In there, we're going to return true, and just below, we're going to return false. Down below, we are going to set our value. We can call it Boolean. So let's do const bool is going to be equal to the return of this function. So we set this equal to the function invocation, and then we can finally console log the Boolean. What do you think this value is going to be? Is it going to be true or false? If I save this, we do get true. That's because it's the first return value in this case, and of course it is the one that is returned from the function. The first return statement immediately stops the execution of our function and causes our function to return true. The code on this line, return false, is never executed. We can test it by adding some console logs inside of our function. For example, on the top of our function, I'm going to create a console log that is going to just have the value of 1. Below, I'm going to add the console log with the value of 2. And then, even more below, I'm going to add the console log with the value of 3. What do you think? Which console logs are the ones that we're going to see in the console? As you can see, we only got the console log with the value of 1. As soon as the function returns something, in this case true, it doesn't care about anything else. It's done its thing, and now other JavaScript code can be run. In the next video, we are going to explore arrow functions, the modern way of writing JavaScript functions. And that time came. Now we are working with arrow functions. From now on, you'll only see me write these. They're the most modern and most concise way of writing JavaScript functions. At the start, they're going to look a bit weird to use, but once you start using them, you'll see how concise and simple they are. They have only one difference from, let's say, normal functions. Arrow functions do not create their own this value. This is a special JavaScript reserved keyword. We are going to explain it later in more detail. The only thing that you should know right now is that arrow functions do not have the this reserved keyword. In 99% of the cases, we are not even going to need it. So you'll see me write arrow functions almost always. So how does an arrow function look like? Let's take our square example from the beginning. It looks something like this. Const, so we declare arrow functions using normal variables. We can be const or let, and then we have the variable name as always. Then we have a set of parentheses, and then we have an arrow which points to a function block. Again, I know at the start it's going to look a bit weird, but as you get used to it, you'll see all the power that they have. So in here, this is a set of parentheses, and in there you can set some parameters. In this case, we're going to take in a number, and then in here we can return, as we did before, a number times a number, just like that. I personally cannot do a lot to help you remember the syntax. That thing you're going to have to do by yourself. So this is never going to change. It's always going to be the same thing. Const, function name, and then the equal sign, parentheses, all the parameters that you have, and then an arrow sign. If you didn't notice, this arrow is actually the equal sign and then the larger than sign. It just joins them for me because I have the font installed. So it's just the equal sign and then the larger than or greater than sign. And then it points to a function block, which is just a set of curly braces. This is the syntax you will need to remember. But once you write 5 functions, 10 functions, 50 functions, it's easily going to get in your muscle memory and you'll be just writing arrow functions really quickly. Great. So our specific function in this case returns a number times a number, and it accepts one number as a parameter. Let's make a function call right here to see what do we get with our result. So in there, I'm going to create const result, and we're going to make that equal to a square of, let's say, 5. If you take a closer look, you can see that the call or invocation of an arrow function is absolutely identical to the call of a function declaration. That makes it so much easier. There we can make a console log, and let's simply console log the result to see what do we get. Okay, in our case we get 25. If we, for example, change this to 10, we should get 100, and we do, as you can see right there. Arrow functions also have a shorter and more concise version. Whenever we have only one return statement inside of an arrow function and absolutely nothing else, we can return it instantly in one line. To do that, we have to remove this return statement and a pair of square brackets. Then we are left with something that looks like this. In there you can see the name of the arrow function. So this is like an arrow, and there it points or returns to some value. If you think about it, it makes sense. This is a variable, and everything after the variable is a function. Everything after the arrow is the return of that function. Just so we can have both ways side by side, I'm going to create the same function below. So that's going to be const square 1, for example. It also accepts a number. And then after the arrow, we return a number times number. So one more time, when you have only one return statement, you can omit the curly braces and the return statement and just bring all of this in one line, and that's going to be the same. Now we can make a variable called result1, which is going to be equal to the call of the square 1 function. That's this one right there. And now let's also console log the result1. And as you can see, we get 100 and 100, which means that these two functions are identical. As you can see, this one is just a bit more concise. One more thing I'd like to mention in regards to arrow functions is that when you have only one parameter, you're sometimes going to see people just remove the parentheses. So when you have only one, it's completely fine to just leave it without the parentheses. We can do the same thing here, and we can do the same thing here. You can see if you refresh and save, it works. Absolutely the same thing. But when you have two or more parameters, as in this case, A and B, then you need to wrap them in a set of parentheses, because this right now, as you can see, is not going to work. I just wanted to let you know that because some people use this without parentheses. For me, I always like to leave parentheses, even if there is only one parameter. It's just a personal preference. Great, so we went through a lot in this video. I'm 100% sure that for people just starting with this, functions and arrow functions are going to look really, really weird. They have more syntax than anything else we've gone through so far. The good thing is that there is not a lot of logic happening here. You don't have to really figure how things work. The only thing you have to do is just remember how the syntax of an arrow function works. And that's, as I said, always the same thing. Const, function name, equal sign, then we have parameters, the equal sign and the greater than sign connected into an arrow, and then we have the function block with a return statement. In the end of this section, I'm going to leave you some examples so you can practice functions by yourself. Thank you for watching a part of this course. Hopefully, you now have great understanding of the fundamentals of JavaScript. In this video, you learned about variables and data types, operators and equality, and logic and control flow, as well as functions. If you'd like to learn more about tricky parts that are often asked at interview questions, strings and arrays in detail, as well as object in details, and many more complicated topics, definitely make sure to check out the course. There's going to be a huge discount only for people watching this video. If you're serious about learning JavaScript, and if you'd like to learn more, the link for the entire course is in the description. Thank you so much for watching, and see you in the next one.